We're going to work some application problems here. Let's look at our first one. One number is 3 times as large as another. The sum of their reciprocals is 16/3. Find the two numbers. Okay, let's let x equal one number, or well, let's just say one of them. Then the other one must be 3x. Okay, the sum of their reciprocals is 16/3. So the reciprocal of x is 1 over x. The reciprocal of 3x is 1 over 3x, and that's the sum of their reciprocals, and that comes out to be 16/3. Now, to solve this equation, I look for my least common denominator for all three denominators. I see that it's 3x, so I multiply this side by 3x, and I multiply this side by 3x. 3x times 1 over x is 3. There's my plus sign. 3x times 1 over 3x is 1. And then 16 over 3 times 3x, the 3's divide out, and I get 16x. So I end up with 3 plus 1, which is 4, is equal to 16x. I divide both sides of this by 16, and I'm going to end up with, over here, x equal 4 divided by 16, which is 1/4. So one of my numbers then turns out to be 1/4, and the other number turns out to be 3 times that, which is 3/4. And the sum of the reciprocals of 1/4 and 3/4 turns out to be 16/3. Let's look at our next problem. One plane can travel 20 miles an hour faster than another. One of them goes 285 miles in the same time it takes the other to go 255 miles. What are their speeds? So I've set up a little table here, like the tables that we use in the book to do these problems. Let's let the speed, the rate or speed of the first plane be x. Then the other plane is 20 miles an hour faster than that, so it's going to be x plus 20. Now, one plane travels 285 miles in the same time it takes the other plane to travel 255 miles. Well, you can see that this plane travels at x plus 20 miles an hour. This plane only travels at x miles an hour, so it's not going to go as far. So the 255 miles goes with this plane, and the 285 miles goes with this plane. The next thing I want to do is fill in these two squares, and I'm going to fill them in using the formula distance is equal to rate times time. Since I want to fill in the time squares, I'll solve this for t. T is equal to distance divided by rate when I divide both sides of this by r. So distance divided by rate is going to be time, so 255 divided by x, and this time right here is going to be that distance, 285, divided by that rate, x plus 20. So 285 divided by x plus 20. Now, I'm not going to finish this problem, but if I read back through it, what it says is that the one plane travels this distance in the same amount of time it takes the other plane to travel this distance. So that means that the two times are equal, so to solve this equation, or solve this application problem, all I have to do is set 255 over x equal to 285 over x plus 20. So when I do that, I get an equation that involves rational expressions. I clear it of denominators, and then I'm on to the solution. Let's look at our next one. An inlet pipe can fill a pool in 12 hours, while an outlet pipe can empty the same pool in 15 hours. If both pipes are left open, how long will it take to fill the pool? The key is to look at what happens in 1 hour. So the inlet pipe can fill, let's see, if it takes 12 hours to fill the whole pool, then in 1 hour the inlet pipe is going to fill 1/12 of the pool. The outlet pipe, it takes 15 hours to empty the whole pool, so if the whole pool was full, then in 1 hour the outlet pipe would empty 1/15 of it. And then if it takes x hours, that's what we're going to say, let's let x be the amount of time it takes to fill the pool with both the inlet pipe and the outlet pipe open. Then if both pipes are open, it's going to, the amount of the pool that's going to be full in 1 hour will be 1 over x. So I set up my equation this way. I say the amount that goes in 1 hour from the inlet pipe minus the amount that drains out in 1 hour from the outlet pipe must be equal to the total amount, or the fraction, of the pool that's full in 1 hour with both pipes open. So here I have a little equation that involves some simple rational expressions. 1/12 minus 1/15 equals 1 over x. Find a least common denominator, multiply both sides by it. You'll see that I think x comes out to be 60 in this case. So pretty simple problem if you think in terms of 1 hour. So there's some application problems whose solutions depend on equations that contain rational expressions.